I read that if you mix sawdust with water and then freeze it, you get something that's way stronger than ice. Turns out that works, but not very well. So I tried to improve it, and I think I did. 3 months of work all led up to this moment. That's me on the roof of the American Chemical Society, 87 feet above the alley below. And because this is the control, just regular ice, no surprise here, it shatters. I saw the same thing in my basement when I shot it with my pellet gun. I was testing this stuff called Pykrete, basically water with wood pulp mixed into it, then frozen to make a composite. Pykrete has been around for a long time, but I wanted to figure out, well, 1, how does it even work, and 2, could I make it better? I started out with just pine shavings, and while those were freezing, I built my first test rig. Don't drill into the table. It's the #1 rule. Here we go. Test #1. Okay. Not tough. Let's try a Pykrete one. Same rough strength here. Ow. I don't know if this is a good idea. Let's try it. Go right here. It was not a good idea. And also, I didn't even break the Pykrete. Okay, that time it broke. So I found something better than my hand. The problem was, the hammer just broke everything. Huh. But I did notice something interesting. Some of the pine shavings debonded from the ice and are sticking out, like right here. And some of them just broke cleanly where the ice cracked. Next question. Blowtorch. Obviously it melts ice pretty quickly. Look, this is after 20 seconds. And I'm not going to make you sit through all of this, but after almost a minute... Okay, I don't need to start a fire in my basement. That's way slower. To solve my hammer problem, I bought this pump-action pellet gun. The more times I pump it, the more force the pellet impacts the Pykrete with. At 3 pumps, it obliterates normal ice. But at that same pressure... It didn't go through at all. Wow, that is shocking, actually. So I went up to 9 pumps, and it did break. But it didn't explode, like a bunch of it stayed in one piece. And the round, it did not penetrate here. So it absorbed a ton of its kinetic energy. I needed more data. That was fun, but as always, I need to make sure I'm not fooling myself. I'm making a pine shaving tea here to confirm it's actually the pine shavings themselves that are strengthening the ice, and not some chemical leaching out of them, because I am a serious scientist. While that was in the freezer, I started wondering if smaller pine shavings would make the Pykrete stronger. Oh. And will this kill my blender?
This blender was $26. Not bad.
Look how it's foaming. Isn't that funny? I wonder why. Yeah, I mean, it's definitely... That's smaller than it was before. But not small enough, so I went and got a big bag of sawdust.
All right, there you go, buddy.
Thanks so much.
Good luck, you have a good one.
Thank you, you too. There was so much in here that I broke out my big molds, and my medium ones, and my small ones. Everyone goes to the freezer. And my thinnest mold, which just happens to be a hand. 3, 2, 1... That was the pine shaving tea. Well, I'd say that exploded. And this one's water. Tea again. No surprises here. It appears the pine shavings themselves make the difference, not something leaching out into the water. All right, moving on. Time to shoot a hand. Obviously, we need a control hand. Into the freezer. Well, the pellet went right through, but it didn't explode. Falling over did take off a finger. Next question. Blowtorch. This worked great. I'm not going to try it with the ice hand, and it's still in the freezer anyway. Back to the hammer, which broke through the pine shavings without a problem. So what about sawdust? It looks like smaller wood particles do make Pykrete stronger. Oh, look. I'm not sure what that says about how it works, but I have made a stronger version already. Time to shoot the ice hand. And this is when I realized that ice is really brittle. Look, Pykrete, ice. So I clamped it. Yep, ice is brittle. Sawdust Pykrete in the smallest mold versus 3 pumps of pressure deflected the pellet. But at 9 pumps, it broke. In the medium mold, though, the sawdust pykrete held up against 9 pumps of pressure. And the jumbo mold, well, that barely moved. But if the mold is this big, maybe the ice would do the same thing. Nope. Ice is brittle. My pellet gun tops out at like 10 or 11 joules of energy delivered to these blocks, and sawdust already is showing that I need more than that. Enter the drop rig. It's a work in progress. I still need to find better pykrete to test once this thing is ready. After sawdust, I tested so many other things. Iron filings in the hand, aluminum foil, polyfill, which turned out to be so hydrophobic that this happened.
This is... it's just floating on water.
So then I put detergent in the water so that the water could actually penetrate between the polyfill fibers. I threw all that in the freezer, and then I honestly don't know what I was doing here, but remember what I said the first rule was earlier?
Oh, damn it!
Iron filings in the hand somehow worked just as well as sawdust. So what about the aluminum foil? Well, a lot of the ice shattered away, but the aluminum foil itself caught the pellet. And the polyfill without soap didn't shatter, but the pellet went straight through it. The polyfill with soap, on the other hand, caught the pellet. Now we're getting somewhere. Next up, cotton balls in a blender, and sodium polyacrylate, also known as diaper gel, a super absorbent polymer. Boom. And even though this diaper gel isn't a fiber at all, it still deflected the pellet, which is confusing. Like, how does this work? Every flavor of cotton worked even better. Toilet paper, sugar, oobleck, also known as cornstarch, which is like sugar, but a polymer instead of a disaccharide. Bubble wrap, saran wrap, concentrated sugar syrup. All right, all that's in the freezer. And now back to Pykrete's roots. Originally it was made with wood pulp, not sawdust, and I wanted to make some wood pulp, but I don't really want sodium sulfide in this bucket in my basement, so I'll just use sodium hydroxide and let it sit for like a week. Then I'm gonna hammer a nail through some Pykrete.
Aha! Aha!
So it can stop a pellet, but it's still kind of brittle. Iron filings did great. Pellet went straight through the saran wrap, straight through the bubble wrap, and I was surprised that the oobleck performed more like ice and less like the diaper gel. I mean, oobleck is supposed to be non-Newtonian, but fine, physics, whatever. And toilet paper was the best so far.
These are my sugar samples. Oh my gosh.
So I'm not gonna shoot these, but what about gluten? I took some flour and overmixed it to get some really long gluten chains, and I also did unmixed flour as a control. Calm down, chat.
All right, now, freeze it.
While that was freezing, I checked in on my homemade wood pulp.
Oh. Let me just say that it smells how it looks. That should give you the perfect idea.
Strained it, neutralized it, washed it with water, milked it. Made Pykrete out of it, threw those in the freezer, and pulled out my frozen flour samples. Unmixed on the left, overmixed on the right.
Anyway, let's shoot these.
Unmixed, overmixed.
Can you tell a difference?
No.
I mean, if anything, the high gluten one looks a little bit more destroyed.
And now, wood pulp. And I have high hopes.
That is the same, maybe even a little less good than sawdust Pykrete. So, went through all that trouble for nothing.
Now it's finally time to upgrade from 11 joules of energy to 27 joules with my drop rig. Carefully aligned with a plumb bob to drop a 6-pound shot directly onto my samples. You already knew what ice was gonna do, but doesn't this look great? All right, what about sawdust Pykrete? It can stop a pellet. Can it stop a shot? Okay.
It shattered a bit less, like this is the largest piece of Pykrete, but I can't say that it did very well.
What about wood pulp? Will that do any better? Nope. Worse. This is not promising.
And this is toilet paper Pykrete versus 1 meter drop in 3, 2.
Oh! Much better.
Yes!
Look how little damage that did. The toilet paper absorbed the impact so well. Now let's double the energy. 2 meters.
It lives. What the?
Gotta try that again.
Did that crack the paver underneath? The paving stone cracked almost in 2.
Now wood pulp from 2 meters, because why not? Well, I think that test speaks for itself. Oh, and it went through. It cracked both of my paving stones. Did it crack my floor? No. But that's the end of my drop rig, I guess. But I had an idea to go bigger. And for reasons that I still don't understand, the American Chemical Society agreed to let me throw some Pykrete off their 9th floor roof in downtown DC. So I had to get this done before someone CC'd legal. Now, obviously the Pykrete needs to hit the ground in the same way every time. And the only way I could think to do that is to remove all asymmetry. In other words, make a sphere, which was harder than I thought. Come on. But like other things in life, it turns out a little Vaseline goes a long way. Oh, come on. There we go.
This is not a sphere.
So I'm going to freeze it directionally from the top down so that water gets pushed out a little hole in the bottom as it expands. Now, how do I make a toilet paper sphere?
So look what happened.
I should have called that. So I added more.
Do I need more toilet paper in there?
I did. I needed more. And now, after 2.5-ish rolls of toilet paper, this one goes in the freezer and ice sphere number 2 comes out. Hey, I did figure out the ice. I also made a wood pulp and sawdust ball to test a more traditional recipe. That is the White House. And this is me. I needed a way to drop the spheres accurately and without too much forward momentum. So here is the new drop rig. So I guess we're gonna push something off the roof. Okay, here we go in 3, 2, 1. This is the control. It's just ice. Control number 2. Yeah, that never gets old. Now, first real test. This is the wood pulp and sawdust mix. Still shattered, but this looks way better than just ice. So improvement, but not great. And now, the moment that I have been working for this whole time. Toilet paper. It bounced. You can see in the slow motion that it absorbs the impact by spinning, and if I back up and go frame by frame, you can also see that it deforms into a cute little Death Star.
We could bring it back up and drop it again if we wanted to.
Yeah, let's definitely do that. This time, it did break, but only into 2 pieces and not even along the seam. That's incredible. So I have learned that the hydrophilicity of the fibers is maybe not all that important. Maybe you don't even need fibers at all, since the diaper gel worked. Regardless, I've created what I think is a new high-strength building material, and I've done it from toilet paper, water, and cold.